Okay, so now while using the addition formula is pretty useful, we're going to see that using Venn diagrams is also a good way to count things in sets and intersections, whatever. So this is going to be counting using uh, Venn diagrams. And I already did an example of this in one of the previous videos, but let me explain the basic deal. Again, what we're going to do is draw a Venn diagram and draw some sets. This is our universal set U. This is A. This is B. That's their intersection. This is what's outside of them. And when I write numbers in each piece representing how many elements in that piece. So that's the basic idea. So maybe in A intersects B, there are 3 guys. In A but not in B, there might be 2. In B but not in A, there might be 5. And in the entire universe outside of them, there might be 7. So this means, for example, that the number of guys in A is 2 plus 3 is 5, because there are 2 guys that are in A but not B, and 3 guys that are in A and B. The number of guys outside of B, well, this piece is outside of B, this piece is outside of B, so it's going to be 2 plus 7 equals 9. So this makes it easier for us to compute some things. So let's do some specific examples. First, let's suppose that in some poll, some Democrats and Republicans are asked who they're going to be voting for, and so we've got 40 Democrats voting Democrat, and we happen to have 6 Democrats voting Republican, and 5 Republican voting Democratic, and I can hardly see that number, 49 Republicans voting Republican. Okay. So I've got to draw a Venn diagram, but I've got to be careful about what I draw. I don't want to make one set be the Democrats and the other be the Republicans, because those two are complementary sets. I should let one set be D, say, which are the registered Democrats, and say V is going to be those who are voting Democrat, because those are really the two ways that things are being split up, is which party are you and which way are you voting. So I write down my Venn diagram here. My universal set, let me call it P because it stands for polling. And here is set D, which represents political party, Democrat. If you're outside of that, that means you're Republican, although I know they're independents. And V here is if you're voting Democrat. So there are 40 Democrats voting Democrat. That means that right in here we get 40. Now there's 6 Democrats voting Republican, so if you're not voting Democrat, you've got to be here. There are 5 Republicans who are voting Democrats, so they're not in the set Democrat, but they are in V, so they go right here. And then there are 49 Republicans, that's everything outside of D, that are voting Republican. That's everything outside of V. So let me erase what's off to the left, and let's do some sort of examples of computations that you might want to do. So for example, how many Democrats are there? Well, there's 6 who are not voting Democrat and 40 who are voting Democrat, so there are 46 Democrats total. How about how many are voting Democrat? There are 40 Democrats who are voting Democrat, and there are 5 Republicans who are voting Democrats. So the total number here is 45. Finally, we can ask how many people were there total in the poll. Again, P I let represent my universal set. Well, this is just going to be the sum of all of the numbers, everything. Notice that when I found the number of things in D, I added up all the numbers in D. When I found the number of things in V, I added up all the numbers in V. So if I want to find out how many people were polled, I'm going to add up all the numbers. 6 plus 40 plus 5 plus 49, and you can check that that is equal to 100. So let me just note the number of elements in a set is equal to the sum of all numbers in that set S. Okay, great. So that was a pretty simple example. Now, I gave that to us with all of the data already broken up, but that's not always going to be the case. Sometimes we'll be given information kind of like this. So here's another example. This is about the Cuny Schools. Now, Cuny has 23 schools altogether, and 11 of these are senior colleges. And that includes John Jay, Hunter, City, Lehman, Brooklyn, Queens, Meggers, Evers. I'm probably forgetting some. Staten Island, Pauley Honors College. I guess I included in there. I don't know. So some colleges, and there are 10 schools in Manhattan, and of the senior colleges, 5 of the senior colleges, of course I forgot Brute, are in Manhattan. Okay. So let's draw a Venn diagram that represents this scenario. What are really the two different sorts of sets we're looking at right now? We have senior colleges and those in Manhattan. So I'm going to let C be my universe, which is all schools. I'll let S be senior colleges. And I'm going to let M be those schools in Manhattan. So my set looks something like this. Here is C, the universe. Here are S for senior colleges. Here is M for those in Manhattan. And great. Now, I don't have numbers for each individual piece. For example, this piece that's outside of both M and S is those schools which are neither senior colleges nor in Manhattan. And none of these numbers here represent that. The only number here that represents any of these pieces alone is 5, because it represents the number of schools that are senior colleges in Manhattan. Okay, so how am I going to fill out the rest? Well, I know that the number of things total in S is supposed to be 11. I've already written down 5 in here, so that means that the number of guys in the other piece have to be 11 minus 5 is equal to 6. 6 guys in S, but not M. Okay. Now I'm going to remember the numbers here. Now similarly, we know that the number of schools in Manhattan altogether is 10, so that means that 10 minus 5 of the schools are in Manhattan, but not senior colleges. So that's going to be 5 total, and that number goes here. Okay, so 6 plus 5 gives me 11, which is the number of senior colleges. 5 plus 5 gives me 10, which is the number of Manhattan colleges. Finally, there are 23 schools overall. So whatever number is out here plus 6 plus 5 should add up to 23. So the number of colleges is 23. So that means that 23 minus 6 minus 5 minus 5 should give us everything that is outside of both of these sets. And so that's going to be, what? 13 minus 6, that's going to be 7, which are in neither M nor S. So 7 out here. So again, 7 plus 5 plus 5 plus 6 had better add up to 23, and they do. So now I can start asking questions using this data. So what sorts of questions am I going to ask? I'm going to erase everything except for our Venn diagram because that has all of the information that we care about. So I could ask questions like, how many senior colleges are there in the outer boroughs? Well, there are 5 in Manhattan, and there are 6 others in the set S. This number right here, 6, represents those that are senior colleges but not in Manhattan. So the answer for that is 6. Or I can ask something like, that's a silly question. How many you know, I don't even know what to ask. How many non-senior colleges are there outside of Manhattan? Well, if you're a non-senior college, you're not in S, and if you're not in Manhattan, you're outside of M, so that means that you must be in this outer piece right here, 7. If you're in S, you're a senior college. If you're in M, you're in Manhattan. I'm looking for non-senior colleges outside of Manhattan, so that's 7.